Today's objective is to solve a nonlinear system of equations. To solve a nonlinear system of equations, you must isolate a variable by itself, preferably the y, so that you end up not having to plug something in for x squared that is a binomial expression, something with two terms. So you can use the top or the bottom to isolate y. If you look at the top equation, the y up here has a -2 with it. If you look at the bottom, it has nothing with it but a +1. So this one would be the one that makes the most sense. What you can do is to isolate this y by keeping it on the left and moving this x squared to the right, changing the sign. You now have y equal to this expression, and you came up with that from the second equation. So plug this back into the other equation, not the one you just used. Plug this one in up here for y. So x minus 2y equals -2 is now x minus 2 times the quantity negative x squared plus 19. And that equals -2. Simplify this. Distribute the 2 all the way through. Treat it as a -2 and come up with plus 2x squared minus 38 equals a -2. You want to make a quadratic equation from this. You have an x squared, an x, and two constants. You want everything on the left in order in this form. Ax squared plus bx plus c equals 0. So we're going to have 2x squared plus x minus 38 and move the -2 to the left, make it plus. Now go simplify your constants at the end. -38 plus 2 is a -36. You can factor, you can complete the square, you can use the quadratic formula. The easiest one in this case would be the quadratic formula. So that would be a -1 plus or minus the square root of 1 squared minus 4 times 2 times a -36 over 2 times 2. Simplify under the square root sign to have 1, and you have a double negative here, so it would be plus 4 times 2 times 36. 4 times 2 times 36 is 288. On the bottom you have a 4. Simplify even further to get a 289 under the square root sign. 289 is a perfect square. Its square root is 17. And you now have two different problems you must work out. You must do one that is -1 plus 17 over 4, and another one that's -1 minus 17 over 4. On the left-hand side, that would be 16 over 4, which reduces down to simply 4. Or you could have an answer that is -18 over 4, and that will simplify down to a -9 over 2. Those two x answers at the bottom must be plugged back in up at the top into one of these two equations. It would make more sense to use the one without the square in it. So let's use the top and make a note that you have an answer of 4 and -9 over 2 at the bottom. So at the top, we're going to use this. X minus 2y equals -2. X minus 2y equals -2. And if I plug in 4 for x, I'll have 4 minus 2y equals -2. -2y equals -2 minus 4. That gives me a -6 on the right. Divide that -6 by -2 to get a 3. Now I plugged in 4 for x and came back with a 3. That's one of my solutions. I need to use the same equation again. X minus 2y equals negative 2. And now plug in the negative 9 over 2 that we found from before. So negative 9 over 2 minus 2y equals negative 2. Move that minus 9 over 2 to the right and make it plus 9 over 2. Here you are with a fraction that you must add. You need a common denominator of 2, which would make the left-hand fraction negative 4 over 2. So negative 4 plus 9 is 5. 5 over 2, which we now must divide 5 over 2 by a negative 2. When you divide by a fraction, and negative 2 is a fraction because it can be written over 1. When you divide by negative 2 over 1, it's the same as multiplying by negative 1 over 2. So that would give you a negative 5 over 4. And you can simplify that even further to a negative 1 1/4 for your final answer. Now remember, you put in negative 9 over 2. Negative 9 over 2 as a mixed number is negative 4.5. So I put in a negative 4.5 and came back with a negative 1 1/4. So these two items here, this and this, would be your solutions for that system. To solve this nonlinear system of equations, we want to find a variable, preferably y, so that we can get it by itself and set it equal to an expression that we can then plug into the other equation. If you look at this one, getting y by itself here would entail dividing by 3 all the way through. But up here we only have a negative 1 next to this y, so it makes more sense to find this one. So 3x minus y equals negative 7 is the first equation, and we're going to isolate the y. And then we have to divide everything by negative 1 to get that y completely by itself. 3x plus 7 is equivalent to y. So we can plug that into y in the second equation and come up with the following. X squared plus 3 times the quantity 3x plus 7, and then equals 7. We have to simplify this, distribute the 3 through the parentheses to get 9x plus 21. And now we need a quadratic equation of this form, ax squared plus bx plus c equals 0. So we're going to keep the x squared and the 9x and the 21 on the left and move the 7 over with it, changing the sign. Simplify your constants at the end. Since we do not have a number other than 1 on the x squared, this may be easy to factor. Can we get two numbers that multiply to get 14 and add to get 9? And the answer is yes. 2 and 7 will satisfy that. 2 times 7 is 14. 2 plus 7 is 9. So we set each of those expressions equal to 0. And come up with x equals negative 2 or x equals negative 7. Both of which we'll have to plug into one of these top equations up here. And the easiest one would be 3x minus y equals a negative 7. 3x minus y equals negative 7. And one of the answers that we found was negative 2. So if I put a negative 2 in for x, I can go through and solve for y. That's a 6x, or not a 6x, but just a negative 6. And we're going to move it to the right side and make it plus 6. That would give me a negative 1, but I have to divide that negative 1 by negative 1 to get an answer of 1. I put in negative 2 and came back with 1. So there's one of my solutions. So now we still need that same equation, 3x minus y equals negative 7. And we're going to plug in negative 7 for x. So there it is, and we can solve for y. That's a negative 21 minus y equals negative 7. Move the minus 21 to the right, make it plus 21. That's going to give me a positive 14. And now we divide that 14 by the negative 1 from the left and get a negative 14. I plugged in a negative 7 and came back with a negative 14. So your two solutions are this and this.